I heard from third hour that some of you guys in 8th grade did some absolute value graphing, but you did it via tables. So here's what I want to do. There's probably in the back there, I think I got a stack of graphing. Would you mind grabbing that whole stack there and just start passing around? You'll need one for notes and one for homework again, guys.
You're gonna have homework this week? Come on, I have a life. What is wrong?
Ladies and gentlemen, the third hour had 15 minutes to complete their assignment. The less you complain, the quicker we get to the 15 minutes of time to finish assignment. And you know what? Third hour is a lot more than you. All right. Thanks. So here's what I like to do when I first talk about absolute values. What I want to do, what I'm going to do here to start with, to show how an absolute value graph looks like. I always start with the table function, so that way we all understand and remember what they look like. So, since we're using the absolute value, you want to have a couple positives and a couple negatives. So I start with -3, -2, -1, 0, 1, 2, and 3. Now, when you're doing these things, you have to remember, how do you find absolute value? Well,
Just make sure it's positive.
it's not just the opposite. Remember, absolute value is the distance something is from 0. And distance is always positive. I can walk backwards all day long and I'm still going some distance. Okay? So what I'm looking at here is, what's the absolute value of -3? What's the absolute value of -2? What's the absolute value of -1?
Kidding.
Absolute value of 0. Absolute value of 1.
Negative.
Remember, absolute value will always, always, always be positive. Okay? So just for a real rough idea of what this looks like, if I'm going from -3 all the way to +3, we wind up with the following graph.
Oh, the geographic ones on the left?
Yes.
It's mirror.
It's a V. It's a mirrored image. It is symmetrical. Remember symmetry when you had parabolas?
Yeah.
Same idea. Absolute value graphs are symmetrical. They are always symmetrical. Bless you. They are always symmetrical about their origin, their center, if you will. This center is the bottom of the V. That V graph, bless you, can shift anywhere within the grid. And what we're going to do is that this graphing here is an introduction to a style of graphing you're going to see in every section from here on out. Mr. Soto. Oh, you guys can get some?
Yes, I gave them some.
All right. Now, every single absolute value graph, no matter what we do, shares the same properties. And these properties are as follows. A, H, and K. I'm going to explain to you what all of these parts mean. You are going to see these A's, H's, and K's in every single style graph that we use from here on out. That H and K stand for the following. H is a horizontal shift, hence the letter H. The K is a vertical shift, the letter K. Okay? I know.
Yes, it does, Katie.
In my brain it does. That's why it makes sense. So, you have these A, H's, and K's. These H's and K's stand for the center of the graph. We call it the vertex. Your vertex is at H, K. Now, from that statement, I want you to look at the function, what they have here. See how I say it's x minus h? So if my graph, if my given was 2, x minus 3 plus 4. What's my value of h if it's x minus 3? 3, very good. It's positive 3. It's whatever this number is. Okay? So if it's whatever that number is there, x minus 3.
What do you mean? K equals negative?
No. I'm going to show you why here in a second. What's that? No, it's because it's taking it literally. It's taking it literally, whatever that number is. If it said x plus 3, that meant it was x minus a negative 3. Okay? So what happens here is when you're dealing with those h values, the value of h is always going to be the opposite of what you think it is. So if it's x minus 3, the value of h is 3. If it's x plus 4, the value of h is negative 4. The k value stays the same always. And it takes a little bit of getting used to. Usually it takes 3 or 4 problems, and that's about it. Because the way that I start these problems is that I like to label everything very specifically to get it in your minds. And once you get it there, it's fine. Because we use these a, h's, and k's when we graph parabolas, when we graph conics, when we graph trig functions. There's lots and lots of graphing that we do that all have these horizontal and vertical shifts. And the h's and k's don't change. The a values is like your how far it opens up and closes. How fast the sine curve goes up and down, the amplitude, the period is all built upon those values of a's. All right? So, like I said, the vertex is always going to be at hk. If the a value is positive, it opens up. If the a value is negative, it opens down. You guys are probably thinking, wait a second, how can I have an absolute value graph that is negative? Well, if you write it out as negative 1 times the absolute value of x minus 2, you take the absolute value of whatever it is times the negative 1. That's why it can open downward.
So that would be minus 2x, right? X minus 2. No, it would not be.
Right. I'll get there. And then, like, every single one of these graphs will always be V-shaped, whether it's opening upward or downward. If the absolute value of A is smaller than 1, it's wide. Think about a fraction. 1/5 of 1 right 5, it's wider. If the fraction is 5, if the number is just 5, it's up 5 right 1, so it's narrower. That's where they get this. So this A value acts as its slope.
So A is slope.
A is mirroring slope here. Now, the easiest thing to do with these types of problems is just to jump right in and do a couple examples. And like I said, there are some real easy steps that I do. What was that? Very good. When I do these types of problems, especially for the first few of them, I like to make sure that I label out what my A, H, and K is to start with. That way it slows me down, and then I can identify what is it going to do when I go to plot it. So in this case here, the A value was, it's just plain old boring, -1. The H value is -2, and K is 3. All right. From that information, I now know where my vertex lies. I now know that my vertex is going to lie at the HK. Well, the HK is at -2, 3. I also know that it's going to open what direction?
Down.
Down. Why is that?
It's negative.
It's negative. So I know it's going to go downward. So I go to my vertex at -2 and 3. And now all I have to do is walk the slope. The slope was -1. The slope was -1. Down one, right one, down one, right one. If you pop online, I'll have the assignment up there at the end of the hour. All right. It's like 8 of these. So if you've got one sheet of paper, you'll be fine. All right. Down one, right one, down right, so on and so forth. And remember, I said that these things are symmetrical. So if I'm going down and right this way, I go down and left the other way. Same exact count. And there's my graph. There's my absolute value. These guys are symmetrical about the origin, about that vertex. So if you walk your slope down one, right one on one side, just do the opposite, down one, left one on the other.
So pretty easy.
Yeah. In all honesty, once you do a couple of these things, it's like, oh, all right.
I mean, we only have like 8 of them or something.
Yeah, I'm not getting that yet. I decided I'm going to split this into 2 days as well. Remember in piecewise, we did it where we graphed the first day, and then the next day we wrote equations from the graph?
Yeah.
We'll do that on Monday.
Okay.
So, and then I'll show you some other tricks. Next one. I have y equals 1/2 times the absolute value of x minus, get your foot down, times the absolute value of x minus 2, all minus 3. Easiest thing to do to start with is to always identify A, H, and K. A is 1/2. H is what in this case? 2. Very good, bless you. And K is? 3. Good. Is this going to open up or down? Up. Very good. And your center is at?
2, -3.
Very good. So I go to the 2, -3. And what's my slope? Up 1 over 2. Very good. Up 1 over 2. And if I'm going up and to the right, I go also up and to the left. And there's my graph.
Can you only give me only graph 3? That's fine.
I'm over exaggerating it right now because there will be times you might only get 1 dot on one side of the graph depending on the scale and get 4 on the other. But you get, as long as you get the idea of where it's going, you're going to be fine. Okay? But yeah. A is positive or negative? That's it. Okay? Scary? It's bad, scary for a Friday the 13th. Can't do it. I
It
tried.
was close, it was close. I mean, if
We
you
can
don't
count
watch it-
1 to 2.
I thought you
Huh?
Is that what you do for Halloween?
Yes, I'm interested in Count Chocula. Ooh, Count Chocula. They used to make that?
I don't think. Let's remember. Yeah,
Cereal
they
for
do.
The cereal? No, they used to make it like year round.
Yeah, they do.
It was blue. There was Blueberry, Franken Crunch, or was it Frankenberry? And there was Blueberry, and then Count Chocula. Blueberries.
What is this?
A
Cereal. Back in the day when it was okay for people to just eat sugar for cereal.
What happened to those like chocolate eggs filled with candy?
Those were around Easter. When the rabbit that goes.
No.
Chicken.
Like they're like Wonka. They're like big chocolate circles with little candies in them.
So Wonder
They're like chocolate balls.
Like big
I remember
hollow like
those.
chocolate.
Did you guys ever have Cookie Crisp?
Yes.
Cereal. Cocoa Crisp.
No, Cookie Crisp. Where
Yes,
basically
yes.
Cookie Crisp was a bunch of little chocolate chip cookies.
Yeah.
We thought this was a great idea for breakfast. Let's have chocolate chip cookies and pour milk on it.
Oh, just a little. Yeah, they do.
Yeah, they do.
Oh, yeah.
Do you not eat cereal anymore?
No, I don't. It's all sugar.
I had some
No, I really don't eat cereal because if I eat cereal, even if it's healthy cereal, even if I eat cereal, I'm starving in half an hour.
Well, then,
Yeah.
more cereal. Very, very large amount.
What is that silly like that?
What's that?
What is that silly like that?
No, that's why I've already eaten all my carrots. I'm already getting hungry. So try this one real quick. We might call it a day on graphing of these things. I'll give you guys some prompts. Okay? What's your value of A?
Negative 2.
Is there a sheep in here? What's your value of H?
0.
0. If it was 1, you'd see x minus 1. I don't see anything after the x. That means my value of H is 0. I gotta be careful when I did that. There's a point here and I could have really hurt myself. And then K is 3. Doink. I just really wanted to go home. So my center is at H of 0, 3. Down 2 over 1 because it's opening downward. Very good. Same thing on the other side. Not so bad?
Not so
Let me give you some problems. Hey, graphic. Section 2.8, I believe it's on page 112 or 126. Yeah.
Alright.
Mr. Merage again?
126. Okay, begin. You have a clicky pen.
Yeah, Mr. Murphy.
Yes, sir.
When will we be using these in real life?
Someday. I don't remember exactly what day it is, but I think it's a
A
Tuesday.
math teacher.
Yeah, can I take a picture of my phone?
Sure.
I would, but my.
This is, oh, hold on.
I would not.
This is on page 126. I want you to do 18 through 25. Real fast though, guys, before we get out of here. On number 21,
You're a troll.
on number 21, you change your intercept to 10.
Why?
Just so it fits.
do this to us? Like, why?
They're jerks. And I'm awesome.
You are awesome.
I tried.
Yeah.